So we want to find area of this triangle. Well, we have the height. Don't we need the base? Because area is base times height divided by 2. So to find the base, well, let's call that base x. And to do that, well, I need that x. So to do that, let's use trig. Well, for trig, won't that be tangent of 36 degrees is equal to opposite, which is your x, over adjacent, which is 10. So again, of 36, this is opposite and adjacent. So we're using tangent of 36 degrees, opposite over adjacent. And then if we solve that for x, we will have our base. Once we have our base, we can find our area. So to solve for x, we're going to multiply both sides by 10. So we have x equals 10 times tangent 36 degrees. So this right here is the exact length right here. And we want to keep that because see right here, do not round intermediate computations. So that is the exact value of this side. I don't want to find the decimal. The decimal is about 7 something. So if I want to find the area now, area for a triangle is base times height divided by 2. So our base would be the 10 times tangent 36 degrees, and our height is 10. So if we put all that in and use a calculator, we can crunch our area more accurately. Again, we did not want to put the decimal here because that hurts the accuracy, and it said right here to specifically do that. What you're going to end up with for an area when you put that in is 36.3, and that would be units squared. They might not need units, but that's how you would write it. You want to put a fence around your property, which is in the shape of a right triangle. You know the hypotenuse is 60 feet, and an angle is 20 degrees. How much fencing do you need to purchase? All right, so let's draw a picture to start with. So we have a property that's a 90-degree angle, 90-degree right triangle. This right here is 20 degrees. The smaller angle is 20 degrees. The hypotenuse is 60 feet, and you want to find how much fencing to buy. Now for fencing, are we talking area or perimeter? Well, if this is my property, wouldn't it be perimeter? Aren't we trying to find all the sides and adding them up? So we need to actually find both these sides and then add them to 60. So let's take them one at a time. Let me call this x and this y. We have to find x and then we have to find y. Okay. So how do we find x? Well, I want to use trig. So if I think about it, if I'm using 20 degrees and I want to use x, x is your adjacent and this is your hypotenuse. So what is adjacent and hypotenuse? It is cosine. So I'm going to do cosine 20 degrees is equal to adjacent over hypotenuse. And I'm going to solve it for x. And when I do that, I am going to get x is equal to 60 cosine 20 degrees. And then we're going to approximate that using our calculator, which would be 56.4. So this right here is 56.4. But we still need to find this one, which is opposite the 20. So this is going to be opposite over hypotenuse. So we're going to use sine now to find y. So we're now going to do sine of 20 degrees is equal to y, which is the opposite over the hypotenuse. And we're going to solve this by multiplying both sides by 60. And we now have y is equal to 60 sine 20 degrees, which is equal to 20.5. These are both feet, I forgot to say. Now let's go back to the question. The question is, how much fence do I need to purchase? Well, that's 60 of y. Let's write y on there. Y was 20.5, and then we have 56.5. So isn't that the perimeter? How far around? So my answer is really just asking me to add up all those numbers. 60, 56.4, and 20.5. We're going to add all those up, and what we get is 9, 6, and we get that. So it's 136.9 feet or square feet. It's a length, so it's feet. That's how much feet of fencing you would need to purchase in order to put around this property. You have a pile of dirt that is an upside down cone shape. The base has a diameter of 6 feet and the side goes up at a 50-degree angle. What is the volume of the dirt? So first thing we want to do is probably draw a picture. So I have a cone shaped dirt upside down. All right. My cone shaped dirt. Now for this dirt, that right there is 6. All right. It says there's a 50-degree angle. Well, if I draw up, isn't that my height? That's going to be important. And isn't this my 50-degree angle right here? You have a 50-degree angle. Your diameter is 6. We're going to need this height because we want volume. Volume of a cone is base times height divided by 3, and the base is pi r squared. So we're going to need this height. How do we get that height? Well, we have to use trig. Well, do we know this length right here? Yeah. Don't we have to pause and think, okay, what is this length right here? Well, wouldn't that be 3? Because the whole thing's 6, so wouldn't that be 3? And what trig function for this angle uses opposite and adjacent? That's tangent. So won't tangent of this 50 degrees be equal to opposite, which is h, over adjacent, which is 3? And when we solve that, won't we get our height? Our height is equal to 3 times tangent 50 degrees. Now, I'm going to get the approximate for that using a calculator. What I get is 3.58 when you round, and that would be in feet. So that's a height, 3.58 feet tall pile of dirt. Now, I want to find the volume. And volume for a cone is your base times your height divided by 3. Our base is pi r squared. It's a circle. So pi r squared. Our radius is 3. So that would be the base circle, is pi r squared. And the height we just calculated is 3.58. If you wanted to be more accurate, could I have put this in there? And now we're going to crunch this and see what we get. And you will get about 33.7 feet. And this is a volume, so it's cubic feet. So you would have 33.7 cubic feet of dirt.